Welcome to this Operations Management tutorial video on material requirements planning. In this video, we're going to show you how to calculate material requirements for a given master production schedule. Now, I'm not going to read through all of these steps, but rather we're going to jump into Excel in a few moments and do these steps together. But you should know that MRP is a set of techniques that uses bill of material data, inventory data, and the master production schedule to calculate requirements for materials. Material requirements planning is used for components within products, whereas we use forecasting to plan requirements for the top level item. Now, there's a number of inputs into the MRP process: a bill of material, which is kind of like a recipe; inventory status, which tells us how much inventory of components we already have on hand; and then, of course, the master production schedule for the top level item that we are making. And then we get very important output that tells us what should be ordered, what order should be expedited, that's an example of an exception message, what order should be canceled, and what should be de-expedited. These are the main outputs of the MRP process. Let's jump over to Excel and look at the example that's in the textbook. We have a toy car that we are planning the production for. It is composed of two wheel assemblies and a body. And the two wheel assemblies, each wheel assembly is composed of an axle and two wheels. So when you do the math, two wheels on each of the two wheel assemblies makes a total of 4 wheels in the car. However, we work level by level in the MRP process. And note that the wheel assembly is both a parent to its child components and a child to the top level assembly of the toy car. Now, typically MRP is performed in specialized systems or software that does material requirements planning. However, it's good to understand lead time constraints and all the work that goes into producing tangible products. Okay, so here we have the toy car table, the top level assembly. We have the wheel assembly, which is again a child to the toy car. And then we have an axle MRP table and a wheel MRP table, both of which are children to the wheel assembly. Now, I'm going to walk through the steps that you can find in the textbook. We begin by computing our net requirements. Here we have gross requirements, or in other words, the amount of product we need to ship out by the end of this week of August 1st, and we have 0 gross requirements, so our net requirements are going to be 0 in this case. If we have 0 net requirements, and we begin the week with 200 units, and we receive 500 more units, these are scheduled items or a previously committed order that will arrive at the end of this week. So we have 200 from the beginning of the week plus 500 to be received during that week. We are not going to have to ship out any others. There's no net requirements, so we will end that week with 700 units. We do the same thing the next week. 0 gross requirements means we'll have 0 net requirements. And we are not going to receive any more product, so we will end that week with 700 as well. In the week of August 15th, we have a gross requirement of 1,000, and we have 700 on hand at the beginning of the week. So that means our net requirement is 300 units. In other words, we need to produce 300 units in this week to go along with the 700 of on-hand inventory from the beginning of the week in order to ship out 1,000. Now, the MRP logic will look at this net requirement and it will size that net requirement to conform to the lot size restriction. The production policy is that they will only make this toy car in batches or lots of 250 units. So our planned order receipt is going to be greater than or equal to the net requirement divisible by the lot size, in which case this gives us 500 units. And we have a 1-week lead time, so that means we must release that planned order into production 1 week before it is due. So these two numbers always have to be the same. They're really the same number, they're just different sides of the same coin. It's kind of like if you order something from Amazon and you have a 2-day shipping commitment from them. the planned order receipt is the day you are going to receive it, and 2 days earlier is the planned order release, or the time that they have to release that item to have it picked and shipped so that it arrives 2 days later. So again, it's the same quantity, just offset by whatever the lead time is for that particular item. Okay, if we have a net requirement of 300 and we receive 500 from production that week, that is going to leave us 200 at the end of the week. Note that the projected on-hand inventory is the last item we calculate in each of the columns. Moving on to the next week, we have a gross requirement of 0, so our net requirement is going to be 0 as well. Our planned order receipts will be 0, as will our planned order releases in the previous week, and we will still end up with 200 at the end of that week. Okay, well, you see where this is going. We have 1,600 gross requirements the following week. We have 200 to ship toward those 1,600, which means we are 1,400 units short. But 1,400 is not divisible by 250, so we have to go with the next number larger than 1,400 that is divisible by 250. That's going to be 1,500 as our planned order receipts. Again, that's a computer-generated suggested order. And then you'll have a planned order release of 1,500 as well, leaving us 100 projected on hand at the end of that week. We have 0 gross requirements in the week of September 5th, so that's going to leave us 0 net requirements, 0 planned order receipts, 0 planned order releases in the previous week, and we're going to end up with 100 once again. And then we have a gross requirement of 2,000. 100 units that can be applied to that requirement of 2,000 leaves us a net requirement of 1,900. And 2,000 is the smallest number that is greater than or equal to 1,900 and divisible by 2,500. And we have 2,000 then as the planned order release the previous week. Again, we end up with 100 units inventory at the end of that week. We have 0 gross requirements the following week, meaning 0 net requirements that week, 0 planned order receipts, and 0 planned order releases the week before. And again, we end up with 100 units. Now we have 2,400 gross requirements in the week of September 26th. We have 100 units that can be applied toward that 2,400, which means we have a net requirement of 2,300. And again, 2,500 is the smallest number that is greater than or equal to 2,300 and divisible by 250. And so we have 2,500 again as the planned order release for that item. So that is how MRP logic works, and we've done this in a manual fashion. Now let's move on to one of the components. Again, the wheel assembly is a child to the toy car top level or final assembly. And we are told that there are 2 wheel assemblies for every top level assembly, for every toy car. I've added these 2 cells here. They are not in the example in the textbook, but you might want to add those if the homework problems do not give you a quantity per number in the table. So what we're going to do here is we're going to calculate gross requirements. For the top level assembly, the gross requirements were given, but for the children or components in these problems, we must calculate the gross requirements. And the gross requirements for the child are equal to the planned order releases, not the gross requirements of the parent, but the planned order releases of the parent multiplied by the quantity per required for that parent. And I'm going to anchor that so that we can copy this formula across the range here. Okay, so we have 0 planned order releases of the toy car in the week of August 1st, so we're going to have 0 gross requirements for the child, the wheel assembly in that week. But I drag that across, and it gives us all of the gross requirements for the child. Now, let's do something a little bit different. Let's do the same logic, except we're going to automate it a bit. I'm going to write here some tips for you to do this. In this row, the row of the projected on hand, we're simply going to use a formula, and I'll give you a chance to do that before I show you how to do it. Net requirements, we're going to use a max formula. For the planned order receipts, we're going to use a ceiling formula, and for the planned order releases, we're going to use an offset formula. Now, I'm going to let you pause this video now that you understand the logic as demonstrated in the top level assembly table here, and see if you can figure out how to write formulas using these functions to come up with a more automated process for determining the MRP requirements for the components or the children in this example. Okay, well, hopefully you had some success. I'm going to walk through this now and show you how to do this. Okay, the net requirements are equal to, and I'm going to write a max formula, the maximum of the gross requirements minus the scheduled receipts minus the projected on-hand inventory, comma, 0. In other words, if we have more projected on-hand inventory and scheduled receipts, then I want the net requirement to be 0. Now, one other note I failed to mention earlier is your scheduled receipts row is something that you should not change in any of these tables. That'll be given data, and we do not change scheduled receipts. A scheduled receipt actually is nothing more than an approved or graduated, quote unquote, planned order. So an exception message or an MRP output, as we saw earlier, would consist of a planned order or planned orders that are suggested by the software. And then a buyer would actually review those planned orders and then quote unquote graduate them and convert them into actual scheduled receipts, locked and loaded, committed production orders or purchase orders if it's a purchase item. And so the next time we would run MRP after approving planned orders, these planned orders would no longer appear down here, but would appear up above as scheduled receipts. All right, well, enough of that tangent. Let's get back to this formula. So we can run this across with our max formula, and we can see that we have 1,500 units on hand, and we have not carried across our inventory, so it's saying we have 1,000 net requirements in this week, but that is really not the case. Let's do this formula here. Our ending inventory is going to be equal to our beginning inventory plus our scheduled receipts plus our planned order receipts in that same week. The beginning inventory is from the previous week minus the gross requirements. And so in this case, where we have 0 gross requirements, we're not going to receive any more product either. We're going to end up with 1,500 units at the end of this week. Now I can drag this across as well, and we can see that when we have a gross requirement of 1,000 and we have 1,500 on hand beginning that week, we would end up with 500 units at the end of that week. And then when we move into the next week, 2 weeks forward I should say, August 22nd, we have a gross requirement of 3,000. We only have 500 that can be applied to that 3,000, which gives us a net requirement of 2,500. So it looks like our net requirements formula is working correctly, so it's time to move on to our planned order receipts. Okay, let's do it right here under the 2,500, then we can copy it back through the whole table here. Our planned receipts are equal to, and we're going to do the ceiling function, and the number we want to key off of is the net requirement. But we want to do it to the significance of the lot size. And I'm going to anchor that lot size because we have to copy it backward and forward. And in fact, I'm just going to copy the column reference. So I'm going to hit F4 again, so I just have a $sign in front of the B. Close parentheses, hit enter. So again, we have a lot size of 800, and so the smallest number that is greater than or equal to 2,500 but divisible by 800 is 3,200. So it gave us the right number. Okay, let's drag it across to the right, and let's drag it back to the beginning as well. Okay, now we get to move on to the offset function. We have a 1 week lead time for this item, so we want to write a function or write a formula such that 3,200 appears in this cell here, G17. So we're going to use the offset function equals offset, open parentheses. The reference is going to be the cell right above this. We want to grab a cell from the planned order receipts row, row 16, comma. The number of rows up or down from this reference is going to be 0. We want to stick with row 16. The number of columns we offset, you guessed it, is our lead time. And we're going to anchor that only the column reference, so we can copy this to other tables as well. And then we're going to close that. And so there we have 3200. We can drag this to the right. And we can drag it to the left to fill out this entire row. Now this is really slick. Let's say we had a 2-week lead time. All I have to do is input 2 into this cell, and you'll notice that all of these numbers will shift over to the left by 1 week. There you have it. But again, we are told that this has a 1-week lead time, so we're going to stick to 1 week. So now we've created all of these formulas to help us do these automatically. And so I can take all of this information here from the projected on hand and go all the way over to the end of the range, copy it, and I can paste it into projected on hand right there for the axle, and for the projected on hand here for the wheel, and it's going to give us the proper calculations. The only thing we have to do now is calculate the gross requirements for these items. So the axle is a child to the wheel assembly, and if we go back to our bill of material, we see there's 1 axle required for each wheel assembly. So we come here, the gross requirements of the axle of the child are equal to the planned order releases of the parent multiplied by the quantity children required for each parent, and I'm going to anchor that, hit enter, and so we'll drag this across. Here we have it. Our table is complete. And we'll spot check that. Yeah, we have a 1-for-1 relationship between the planned order releases of the parent and the gross requirements of the child. All right, let's do the last one, and this is the gross requirements for the wheel. Now let's be careful. The wheel is not the child of the axle. The wheel is the child of the wheel assembly, and there's 2 wheels required for each wheel assembly. So we will write our formula equal to the planned order releases of the wheel assembly times the quantity of wheels required per wheel assembly. Anchor that, and we'll drag this across. And it gives us our gross requirements for the wheel. And we can spot check it. Notice we have a 2-week lead time for this item, and so there's 2 weeks between the planned order receipt and the planned order release. Alright, well, I hope this video has been helpful. If you really like this kind of work and the detail orientation that is required for it, operations and supply chain might be in your blood. Alright, hope this is helpful as you tackle these homework problems.